All right, you get to see my shirt. I wear a math shirt every Wednesday. That's at least what I'm doing this year. Oh no, and there's your pictures. My bad. You can sue me now. Your picture was on YouTube. All right, you can't see it up there because I have the screen frozen. All right, so we're gonna do solving systems today, and then also solving literal equations. So jump right to that. Just that is the question, and that's what we're gonna solve for a system. What you should know, don't say that, Mr. S. No, but what you should remember from yesterday is these are both lines. That's a line with a slope, and that's a line with a slope. And I'm not going to graph these two lines, but let's pretend that this is the graph of the first one, and this is the graph of the second one. Just making up something. That right there, where they intersect, is the solution to this system. So we remember that, I hope. And I hope that this is, something that just is coming back to you. And back in the day, you probably did solve by graphing, because then it practiced graphing lines, slope and y-intercept, and then the idea of what a solution actually means. Then you moved on to a math way of doing it, an algebraic way. So what this implies, though, and I'm not going to do the second one because I don't think we need two examples of this, your answer should be a coordinate at the end, because that's where these two lines cross, a coordinate. All right, all coming into focus here. So here's substitution. I think this one's ready. This one's ready to solve for y. That's what the first step said. Isolate one of the equations for one of the variables, I think is kind of like how it was worded. That just means take one of the equations and solve for one of the variables. It doesn't matter which one. So I added 2x to both sides. These are the math skills that I should not have to put plus 2x, whatever I do to one side, I do to the other. And then here's step 2. You take this, wherever there's a y in the other equation, and substitute it. So you get rid of that y, and in its place you put what's equal to y, which is 2x plus 4. So 3x plus 2 times 2x plus 4 equals 1. And then you use your solving skills from 2 days ago when I did the whole solving equation unit. All right, which we did say you should know and need to know how to do this, but we'll go ahead and do some examples. You get 1 day of practice for remembering. That's Cat, me out. Distribute the 2. Not going to bother you today. There is a class in here. We got a shortened class. Fumble. I don't know if you heard that. Someone dropped something. All right. And then subtract 8. 1 minus 8 is negative 7. So x equals negative 1. Don't have to show all that undo operations. Even in skipping steps, I still have like 5 steps of work. Expectation of you. And many of you are actually there. Now here is the last step. It says substitute. You only got half of that coordinate, the negative 1 for x. So now you need the y coordinate. And as long as your math is fine and you did the right thing and all your math skills are good and you didn't make any math mistakes, it doesn't matter which one you plug this into. So I'm going to plug it into the one where I got it reset to y equals, the yellow equation, and plug in negative 1 for x. Negative 2 plus 4 is 2. And then I would like you to write it as a coordinate when you're done, because then you're kind of telling me that you know this is what's going on behind the scenes. It's where these two lines cross. But really, guys, why it's the solution to the system, when I plug these numbers in to the original equations, it makes both equations true. And this is what solving is, just like it was 2 days ago. So 3 times negative 1 is negative 3. 2 times 2 is 4. 4 plus negative 3 is 1. Check. True. Negative 1 times negative 2 is 2. Plus 2 is 4. Check, baby, 1, 2, 3. That coordinate solved both equations. That's why it's called the solution. All right, next one, my favorite method is elimination. And I'm only going to do this one and then example 5. I don't think we need too many of these. My favorite's elimination. Sorry, if you want words, go ahead. But what you need to do for elimination is multiply one of the equations So that one of the variables is an opposite of each other. You know, one or both equations by a constant to obtain coefficients that differ only in sign for one of the variables. And then you add those two equations together. Sometimes this method is called linear combination because you're combining two equations into one. And then you solve for the leftover variable and then you substitute. It's the same process as the substitution steps, except for the beginning. So multiply to get opposites, add the two equations together, solve, then substitute. Oh, wait, because I see some people writing the words down super fast. 5, 4, 3, 2. If you need me to go back up to this later, tell me after I'm done with the video and the notes. But I don't think it should be a problem. The words aren't as important as the actual process. Okay, get ready. I'm going to ask a 3, 2, 1 and then prove that you're in this class for the video. What number am I going to multiply the top one by so the x's are opposites of each other? 3, 2, 1, go. Not just 2. 3, 2, 1, go ahead. -2. Could you hear them? I don't think so. They're quiet in my 5th hour. -2 is what you want to multiply. And you do have to distribute that all the way through. And since I took the top equation, I can multiply it by -2 and write it right below this equation. So then I can go ahead and do step 2, which is add these. Linear combination method. Combine these two linear situations. Wachow. This becomes -8y. This becomes -32. Okay, so y equals 4. So we're right back where we were with the substitution method. We got one of the variables solved for. Now we got to find the other variable. Take any of these two equations. I just feel like the top one seems a little bit smaller numerically. Actually, the bottom one's kind of small too. So top or bottom equation, substitute that y equals 4 in. And then you solve for x, right? Super simple, super basic day, half of your homework. By the way, this is 20, so we should know that subtract 20. And then x equals -3. But I want you to make it a coordinate. Please don't write y comma x. It's x comma y. X is -3, y is 4. One special case, which will lead to another special case. But I'll take a breath here. I do have people writing math, NASA. Love it. Anyone notice my bear over here, the Star Wars bear? That was 2 years ago before COVID, the stress bear. If I stress people out in class, they would get to hug the bear. And just. But now because of COVID, that's a transfer of a COVID diseased animal now. Are we done? Okay. Hey, write this one down. Yoink. And guess what I'm going to do? My favorite is elimination. As you're looking at this, in 3 seconds, what am I going to multiply this by to get rid of the x's? 3, 2, 1, go. Did you hear them? They did say 3. Uh-oh. Does anyone ever see what's going to happen? You get -6x, -15y, 27. And then you take this equation and write it below it. 6x, good. Uh-oh. 15y equals -12. What happens, everybody? Not only did the x's get eliminated, what else did? So did the y's. And you know what's going to happen on this? Exactly what happened with solving equations in this occurred. And what has occurred? You lost your variables, but what's left over is true or false. Is that true or false? Last hour said true. I'm like, wait, let's hold on a second. 0 equals 15, true or okay. False. What did that mean for equation solving? Things tootin'. You know what that means about these lines? What kind of lines don't have a coordinate that they share? Parallel. You got parallel lines here. So of course they're not going to cross. Well, you don't know that they're parallel. You'd have to solve for y, both of them, and see that they have the same slope. But that's what's going on there. Okay, let's pretend, not do another example, but let's pretend you have an example, and you start the process. You know, whatever. I don't know what I'm writing here, but you start trying to solve the system, and you end up with this 7 equals 7. So you lost your variables, but what's left over is true. Be careful. What is the answer? And the answer is not infinite amount of solution. Wrong. The answer is not all real numbers. Gosh dog it. I just said what the answer is. What is the answer? There's a difference. See? What this means is they're the same line. So they're right on top of each other on a coordinate plane, but they're not every coordinate as a solution. They just share the coordinates that they share. So you cannot say all real numbers in this case. You do say an infinite amount of solutions, though. And it's whatever the equation of the line is. It's only those coordinates. So there's a big difference between all real numbers and infinite amount of solutions. They don't mean the same thing. And I want you to understand that. Got it? Question? No. No, you would not. Yeah, you definitely wouldn't. That's a very. He asked, would you write that as negative infinity to positive infinity? Absolutely not. As a matter of fact, you would never use interval notation in solving systems. And you know that's not interval notation, right? That's a coordinate. That's what's crazy about interval notation. It can look like that too, but it's not. It's just one coordinate, you know? So that's what the interval notation is never used in solving systems. Okay? All right. Now here's for something completely different. And this is why we're doing this, because it is kind of simple. It is kind of like equation solving. I probably could have had this 2 days ago when we did the equations unit. So it is kind of jumbled around. I get it. But here's what a literal equation is. It's what a science teacher does. Probably chemistry or physics. You have a bunch of formulas, and they have you reshuffle the formulas in terms of a different variable. Anyone? Is that true? Don't you have science teachers do that? I think someone's shaking their head. Then they yell at us, like, how come these students can't do that? That's a math skill. What are you doing in the math department? That has happened before. In a kind of funny way. Mr. Bean gets on me a lot of times. Anyone have Mr. Bean? Oh, he's awesome. Love that guy. I just found out he put in for his retirement, so he's going to be leaving shortly. That makes me sad. In the next few years. Okay, here's where you got to make this simple. But here's what students misread. All right, and this is what they misread. What are the operations happening here? It's multiplication. How do you undo multiplication? Division. I think people subtract all the time on this question. What? All right, you got to assess what is your operation that you have, and then just go to grade school. When I solve my undo operations for multiplication, it's division. Because what you need to do, and if you have a highlighter, do it. When they ask you to solve for a particular variable, highlight it. Really focus on it. And what it says is that's the antisocial variable. That's the one that wants nobody else around it. That's who we're solving for. And then I can't make this anymore. There's nothing else I can be fancy about this. If it's multiplication times the variable I'm solving for, undo the multiplication. So it's division, and this is done. By the way, what is that formula? What's C stand for? Anyone? It is a circumference formula. Now, this is actually how people found radii. They actually would measure a circle out in the ground. It's true. I had a book called The History of Pi. Anyone want to borrow it? Nobody. All right. History of pi. They would actually draw circles in the ground. And it wasn't the radius. They would compare it to the diameter. And that's how they got the estimation of what pi is. They were astounded that every time they did the circumference of a circle divided by the diameter, they would get pi, like this 3.14 decimal, no matter how big or how small the circle was. It just blew people's minds that this was a constant in circles. Anyway, a little random nugget of information from Mr. Samuelis's useless knowledge. Hey, what's this formula for? What's F and C stand for? Anyone? 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 Bueller. Yes? Fahrenheit and Celsius. This is to convert Celsius to Fahrenheit. If you had the Celsius, you throw it in for C and then calculate, and then that would be the Fahrenheit. If I have 100 degrees Celsius, what is that in Fahrenheit? Anyone? It's a lot. Anyone? Yeah? Yeah, that's the boiling point of water, so 212. So if you put 100 in for C, you get 212 for F. But anyway, we're going to solve for this. Now, this last hour got this wrong. So what do you undo first? Do you undo multiplication or do you undo the addition first? 3, 2, 1, go. Did you hear a couple? It was one of each. If you undo the multiplication first by division, then you'd have to divide that by 9/5 as well, and that. And it's not the way to go. So what should you really do? Undo the addition first by subtraction. And then actually, I said something that I'm not going to do. I'm not going to divide by 9/5 because a lot of students don't know how to do that. Like, what happens? What am I going to multiply this by to get rid of the 9/5? Raise your hand if you know. And everyone should know, yes. Go tell your counselor. No, stop complaining to them. You should know your fractions. What's the answer? What's the answer? King? 5 over 9. Good. I like that shirt. Is that somewhere where you're going or no? My brother went there. Nice. 5/9. And you were going to say that over there, right? You multiply by the reciprocal. All right? Bam, bam. And then that gets me C. Okay, I'm going to do something. I'll write the final answer just with the parentheses. This is an option. I don't know what happened with my F there. Sorry. Got a little squiggly there. Then I'm going to go ahead and distribute that. And then show some more fancy fraction work. Just because it's going to help you in the future. 32 is 32 over 1. So 32 gets multiplied by 5 only. 32 times 5 is 150 plus 10, which is 160 ninths. So that's if you distributed and didn't use your calculator. And that's true. I do want you to know that 5 only gets multiplied by 32. That's how you multiply fractions. Numerators times numerators, denominators times denominators. The denominator is 1 here, so 1 times 9. All right, moving along. Oh, please. What's the undo operation for getting t by itself? Add, subtract, multiply, or divide? Divide, and it's divide by r. This is distance equals rate times time. This is the most Mickey Mouse example you could ever see. So to get time, take your distance you traveled divided by your rate, and then that's how much time you traveled. But anyway, so again, look how I highlight who they're focusing on. Can I move? It's embarrassing I even had that one. All right, this is I kind of like this one. Okay, yet again, what do you get rid of first? The multiplication or the addition? It's always the addition or subtraction you get rid of first. I am going to highlight the variable as you write this down. By the way, what's P stand for? Looking at this formula, what does the P stand for? Perimeter. It's perimeter of a rectangle, right? 2 times the length plus 2 times the width. Okay, so understanding that the undo of addition is subtraction, understanding that these cannot be combined, which makes my life easier. I just got to write them like that. And then now I get rid of the division or the multiplication by division. And then I will show you something. I'm going to put a little crooked on that L there. I don't like that that looks like that. Can I cancel the 2's, everybody? Yes or no? No. 6 over 5 equals 2 error. You can't take part of a binomial and just cancel one part with something else. But you can do this, and I do want you to know this. This is the reversing a common denominator. They do have a common denominator too, so I can separate this into 2 fractions. And then 2w over 2w is a big fat W. So what I did is I split this into 2 fractions, and then I canceled these 2's. Now that I wrote this like this is true. The only reason I do that is, what if this was multiple choice? this possibly could be the listed answer, not the other one, and you would have to know what to do. That's why I kind of showing you that. But I do like to show you like some alternate things there, and again, it has to do with fractions. I only have two more. Stick with me because you better put a star by this one. Big fat star, because we're in cat, meow. And I'm going to expect you to be able to do this on the test. It might be exactly this question. It really very, very possibly could be that this is the test question. Maybe it has a minus instead of a plus. Really isn't a big deal. It can be very, very similar. You know what the big problem is, though? How many y's do you see besides the 4y part? How many y's? 2. How do I solve when there's 2 y's here? It's a big problem. I mean, you can't just subtract this x, y equals, because you have another y over here. You haven't gotten a y isolated to just be one y equals. So here's what you do. Just going to tell you. You want to get your y's on the same side. That means anything that doesn't have a y, get it on the other side. This cancels, this cancels. Do not do anything screwy with this. These are not like terms. So this ends up being negative x on this side. This ends up being, let's say, y minus xy. You could write negative xy plus y. I think that's what I wrote last year. At least what you've accomplished now is gotten these y's on the same side of the equal sign. And then the next thing you're going to do, does anyone know? Raise your hand. Nice! I got 3 hands already. This is awesome. I think you were first. Not divide by negative x. No, it was going to be something else. Did you know? Or is that something you were going to say? Okay, there is a form of division, but it's another word I'm looking for. Factor out a y, which is like, then you got to figure out when I factor out a y, what's left over through division in your mind. So it's, sorry, I'm going to get rid of that. This is the magic of turning 2 y's into 1. I pull y out as a GCF. So factor is what we're looking for there. And then when I pull that out, don't screw this up. This becomes a 1. Because good good distributors are good factors. If I distribute y back in, y times 1 is y. Right? Minus x. There you go. Mathematically, 2 y's became 1 through factoring. Now you divide by this binomial, and then you're done. Can I cancel those x's? Yes or no? No. All right, so it's negative x over 1 minus x. Oh, and I do want to show you something, but I don't want to confuse the kids. What I was going to show you, I'll just verbalize it. You could take a negative out of this bottom, and that turns into negative 1 times x minus 1, and then the negatives cancel. All right? So another possible answer would be x over x minus 1, which is a little bit cleaner. Huh? Are you with me? If I pull out a negative 1, the negatives will cancel, and I pull out a negative 1, that becomes x minus 1. Oh, this table's so light, I thought it would... See my new table? Prize table? The prizes? Anyway. New table, prizes. Okay. All right. And then honestly, this is going to, in one step, be the same question, almost. Hey, if it was 1/2 plus 1/3, 1/2 plus 1/3, what's the common denominator? 6. 2 times 3, right? 1 over x plus 1 over y, what's the common denominator? xy. Okay, so variable land cannot be like we freak out, right? Think of it that way. If this is 1/2 plus 1/3, 2 times 3, 6 is the least common denominator. Whatever you do to one side, say it. We're going to multiply both sides by xy. What you should know, he keeps saying that, is the numerator gets hit with this x. It's xy over 1. The whole point of me multiplying by xy is to get rid of the, anyone? Starts with an F. Anyone? Fractions. So I really shouldn't have to write that step, but I will today. so that you see and understand how fractions multiply and why I made the choice that I made. And then, isn't this almost exactly the same as the last question? Oh, my bad, dogs. Did it say what I was solving for? No, it didn't. Let's pick x this time. Let's solve for x, which is really ultimately the same process. Okay, same problem. If I wanted to solve in terms of x, then I would need to get everything on the same side. So I'd have to subtract x, not everything, everything that has x on the same side. So subtracting x from both sides, and then factoring. Factor out an x, this ends up being y minus 1, and then divide. Almost identical to the last one except for one extra step. And then if I just cancel that out, that's the answer. A circle like that, so I don't have to rewrite it. And that's all she wrote. And this is why last hour they were kind of half listening, and then they were doing their homework because they know what they're doing. And I'm totally fine with that. If we are still struggling on these concepts, we need to be hitting that tutoring in the math office.